Hi, everyone, and thanks for joining me for episode 770 of People Behind the Science. Today, we are resharing our interview with our guest, Dr. Erin Conwell, originally released on November 7th of 2016. Listeners, Erin studies how young children learn about the structure of their native language. She's conducting studies to determine how children understand what we say to them and how they produce words, sentences, and phrases that are understandable to us. She also examines how children's understanding and representation of languages changes over the course of their first 6 years of life. And in our conversation, Erin shares wonderful stories from her life and research. So I hope you enjoy this episode of People Behind the Science.
Every day, discoveries are made that will change our understanding of the world around us. Dr. Marie McNeely is here to bring you the brilliant minds who are making these discoveries so they can share their incredible stories and take you on an amazing journey. Welcome to People Behind the Science.
Hello, everyone, and welcome to another episode of People Behind the Science. Today, I am thrilled to introduce you all to Dr. Erin Conwell. So, Erin, thank you so much for joining us on the show. How are you?
I'm doing great. Thank you for inviting me.
Wonderful. We are thrilled to hear more about your life and your science. But let me start by introducing you to the listeners. So, listeners, Erin is an assistant professor in the Department of Psychology at North Dakota State University. She received her PhD in Cognitive and Linguistic Science from Brown University, and she conducted postdoctoral research in the Department of Psychology at Harvard. And now Erin is here with us today to talk about her journey through life and science and some of the experiences she's had. So Erin, today we are excited to get to know you both scientifically and personally. So can you start by telling us a little bit about your life outside of science and how you spend your time?
Well, the biggest thing I do outside of science, if I can really say it's outside of science, because I think I am always taking a scientific approach to the world, is that I have a husband and a 7-year-old daughter. And so they are part of the bulk of my time outside of work. And as someone who studies childhood development, my focus was on early childhood. My daughter's out of that range now, but I still find myself observing from a more scientific perspective than I think I might if it weren't for my background and training, what she does. I also enjoy reading. I read usually between 80 and 100 books in a year.
Oh, wow.
And I also knit. And since I've moved to North Dakota, I've taken up curling. So I do that. That's the sport with the big, heavy rocks on the ice.
And the brooms and the, yeah. So is it as fun as it looks? Because it looks awesome.
It is a lot of fun. It's easier than it looks to get started too. So anyone who has ever been interested in curling, I say give it a try.
Well, to all our aspiring curlers out there, you heard it here. I love it, Erin. It sounds like you have so many fantastic things going on. You mentioned you like to spend time with your 7-year-old. Does she have a favorite activity these days?
These days, she likes riding her bike and she is getting pretty into roller skating.
Ooh.
That's something we've been doing together.
Exciting and perhaps a little scary as a parent.
Well, I'm more scared for me than for her. I have farther to fall.
Gotcha. Well, fantastic to get a window into your life outside of science. And I'm quite impressed. You mentioned you read 80 to 100 books a year. I'm lucky if I can get like 6 most years, but I love getting book recommendations from everyone we have on our program. So do you have a book or maybe a few books that you've really enjoyed that we should check out?
I recently finished a book called The Warmth of Other Suns by Isabel Wilkerson, which is about migration of African Americans from the Jim Crow South into the urban areas of the North, which was very, very interesting. And then in terms of books about science, I tell everyone to read Sam Keene's book, The Disappearing Spoon, which is about the history of the periodic table and is a lot of fun. So many great stories in that one. So those are 2 that come to mind.
Awesome. Well, The Warmth of Other Suns and The Disappearing Spoon, I will put these on our book list for our listeners to find. And I have to ask, how do you fit in so much reading time in the year?
I don't have a television.
Ooh.
So I don't watch TV or anything like that at home. So most of my relaxation time is spent reading, and then I fly a lot. So I get a lot of reading done on airplanes.
Awesome. Well, listeners, we'll add these to our list, like I said, on the website. And Erin, we've heard a little bit about your life outside of science, but I do want to talk about your research next. So can you give us the high-level description of what you do as a researcher, if someone perhaps is not familiar with your field and asks you?
Sure. So my official technical field is developmental psycholinguistics. And what that means is that I study how young children, my population of interest is age 6 and younger, learn about the structure of their native language and learn how to understand what we say to them and how to produce words and phrases and sentences that are understandable to us. So that's my research focus, is on how children's representations and understanding of language change over the first 6 years of life.
Very interesting. And with your daughter there as a test subject almost, was there a lot of things that you found yourself watching in her early years as she was developing languages?
Absolutely. I think lots of parents record their children's first steps or their first words, and I did record both of those, but I also recorded her first structural overgeneralization, which is an early marker of understanding of language. So as soon as she produced one, I was very excited. I called my mom.
Yeah.
So that informs sort of what I find interesting and exciting about what she's doing. Absolutely.
Well, that is awesome. Wonderful to hear more about your scientific side. And we'll chat more about specific projects as we go through our conversation. But I think in this introduction, we've chatted about a lot of different things that you like to do in your life. And I think it can be hard to juggle them all sometimes. I'm always looking for motivation and inspiration from everyone I talk to keep me going. So do you have a particular motivational quote or something that really keeps you going?
In terms of motivational quotes, I don't actually have a ton of them, but the one that comes to mind first is always the one from Winston Churchill. That is, if you're going through hell, keep going. Mm-hmm. As far as inspiration goes, I don't think there's much better. That when things are bad, you just have to plow through and keep going and not give up.
Well, I think that is a fantastic motivational quote. And I think as a scientist, you find yourself in these lows oftentimes. And you're right. You just have to keep plowing through it. You just have to make it because there's always a light at the end of the tunnel.
Absolutely.
So I want to also chat a little bit about some of the people who you have encountered over the course of your career. I think as a scientist, you meet so many people and there are so many sources of inspiration out there. Is there one particular person or maybe a few people who you really have thought of as role models or people who've inspired you?
One of the things that's sort of unique about my field is that it is majority female, which is unusual in the sciences. So most people who are developmental psycholinguists are women, which means I've had a load of really great role models for things like how to be a scientist and a mother and how to navigate academia as a woman, which I think is a little bit different than navigating academia as a man. But I would say that the person who has been my biggest inspiration in terms of being a researcher and being a scientist is actually my grandmother, which I think is maybe a little unusual because she was not ever able to be a researcher herself.
Gotcha.
She got an undergraduate degree in chemistry in the 1940s. Mm-hmm. And then when she entered the job market, they told her she got hired right away at a paint company and was told that her job was to clean the equipment.
Really?
And she decided after a while, as she saw men getting hired at the same level and with the same qualifications being given more interesting jobs, she made the decision to leave the research sector and she became a high school science teacher. And so I think a lot about the opportunities that I had that she didn't. And that's really a source of inspiration for me, that we've come a really long way in just 2 generations in terms of what women are able to do, even if we still have a long way to go. And so that idea of forward progress, I feel like I can't squander the opportunity to be a researcher given that she was unable to be one.
Certainly. And then as a science teacher, was she one of these people who was inspiring you and getting you excited about science from an early age too?
By the time I was sort of old enough to really know what her job was, she was no longer teaching science. She was a school librarian. She was semi-retired.
Gotcha.
But she would bring me so many books, which is probably why I am such an avid reader now, but always very, very supportive of me all the way through in terms of pursuing academic work and pursuing science. She was always a big supporter. The rest of my family also big supporters, but my grandmother really an inspiration in that way.
Absolutely. Well, I think the support structure, the support network as you're going through your career is so important. And it kind of helps keep you motivated and inspired as you're going through your career. And like knowing you have these people to report back to and talk about these exciting things. Like you mentioned your daughter's first developments in different areas of linguistics. So very cool. So now tell us a little bit about what is the one thing that you remember maybe turning you on to science to begin with, all the way back in the beginning. What first lit that spark for you?
It took a sort of roundabout path to my particular field. I think most people in my field do, because it's not something that you find out is even a field of research necessarily until you're relatively far along in your education. I went to college planning to become a mathematician.
Interesting.
And then I found out what mathematicians actually do all day. And I decided that was not for me. I have tremendous respect for mathematicians, but I did not have the excitement and the interest to pursue that as a career. But then I took a cognitive science course to fulfill an elective and sort of had the eureka moment of, wait, hold on, I can study that? That's a field of research? And that was really exciting for me because I had some background in volunteering with children who had various developmental delays. And rather than get excited about therapy, I found myself getting excited about how amazing it is that development progresses typically for so many people when there are so many ways it could go wrong. And so I became very interested in what happens when it goes right and how does it go right so much of the time when it seems like there is always the possibility for something to go awry.
Absolutely. I love that perspective, sort of shifting it, because I think you're absolutely right when you realize how complex a lot of systems of development or just the body in general are. Like, wow, it's amazing that I'm here today.
Yes, absolutely.
So I'm curious, you mentioned that you entered college wanting to be a mathematician, and I'll admit that I don't hear that very often. What sparked your curiosity in math?
I loved math. I don't remember not loving math all the way through elementary and high school, and I had some really fantastic math teachers in high school and entered college very excited about it. And then, like I said, as I found out that it is more about the manipulation of these mathematical objects in particular ways than I had been exposed to before, I wasn't quite as interested anymore. One of the interesting things about language research is that formal linguistics is actually very much like math. It's an extremely mathematical field, or very formal field. And so the things that appealed to me about linguistics were some of the things that had appealed to me about math as well, this manipulation of formal symbols, but with the added twist that it was something that I could observe in the real world in a way that many mathematical principles aren't readily available.
Certainly. Well, wonderful to hear what sparked this interest for you and what kind of directed you towards linguistics. So thinking now that you're an undergraduate, you're getting excited about this field that you've now realized you can study. What took you from that position now to where you are today as a faculty member? Were there some key steps or transition points for you?
Absolutely. The first was getting a summer job as a research assistant in a psycholinguistics lab. That was huge for me because I got to see the daily workings of how you collect psycholinguistic data, how you analyze it, how you set up studies, all the different ways that you can characterize language and at all kinds of different levels. So that really increased my excitement and got me some really great experience as well in terms of learning about the complexity. And from there, it was sort of one lab job after another until I started graduate school.
Gotcha. So then can you tell us a little bit about how you selected your graduate programs or your postdoctoral work?
Well, in terms of my graduate program, I did the very sophisticated approach of typing into a search engine terms that were exciting to me with graduate program at the end of it.
I like it.
And going through all of the results to see and to read about what all different labs were doing. And when I applied to those labs that I felt were asking the most exciting questions. And then once I was in graduate school, I actually had a somewhat poor fit with my first advisor in terms of interest. So we did a little work together and it was clear it wasn't going to work out. So I changed to another lab in the same program, which was a rough transition in a lot of ways. But once I got into that second lab, I was also really enjoying that work. And then in terms of a postdoctoral position, by that time, by the end of graduate school, I had been to enough conferences and I was familiar with enough people that I simply approached people who I thought might be interesting to work with and asked if they were looking for a postdoc. And I was very fortunate that one of the first people I asked said yes, and was able to work in her lab for 2 years.
Well, that is awesome. I think that really highlights the importance of networking and asking, because a lot of these positions, the researcher knows they're submitting the grant or they know they have the grant even before this position is officially posted anywhere. So starting that conversation early is a huge help.
Absolutely.
And now you did mention that when you started graduate school, you ended up in a position where you found it wasn't necessarily the best fit for you. And I think this can be a big challenge for other students out there. So do you have any advice for some students who might be currently in this position where they've started working in a lab and it's really not working out or not optimal? What would you recommend doing to help yourself out?
I think one thing that's important to do from the very beginning of graduate school is make sure that you don't find yourself really isolated from other researchers within a department or within a program, because then you have options. Then when you contact someone to say, hey, I don't think it's working for me in this lab, do you have any space in your lab? That's not the first time they're ever hearing your name. Mm-hmm. That by making sure you have connections with other researchers, other groups, you give yourself more options to move around a little bit. And the other thing that I think can be useful to do is to know what other people in the group are doing. Even if you don't need to switch labs, you don't find yourself in a position where the lab you're in is a bad fit, it might lead to some really interesting collaboration across labs that already exist. And that can also be a lot of fun. Right now, I'm mentoring a graduate student with a colleague, and this colleague and I would never probably have started talking to each other about some mutual interests that we have, because on the surface, our fields look really different. But because the student suggested that there was common ground for us, we're taking a direction I don't think either of us expected, but that's really fun and exciting.
Well, that's awesome advice, Erin. Thanks so much for sharing that for our listeners who maybe are finding themselves in a similar position. And it sounds like you were able to really make the best of it, which is awesome. And it has led you then to your postdoctoral work, like we mentioned, and to this position where you're at today. So can you tell us a little bit about what you're doing today, maybe a project you have going on in the lab that you are super, super excited about?
Sure. So one of the things that I am most interested in is the role of children's experience with language in shaping their understanding and their beliefs about how language works. And traditionally, in the field of language acquisition or language development, there are sort of two camps of people. And one camp says that everything you know about language is more or less innate and is sort of minimally shaped by the environment. And there is another group that says, no, everything is learned. There's no innate structure. And what I'm interested in is sort of splitting the difference and saying, well, what if we assume that some things are innate, that the environment actually plays a pretty major role in shaping your understanding of the structure? So right now, one of the things I'm looking at is how very high frequency words, particular ones I'm looking at right now, are pronouns. So those are words that occur in almost every utterance that children hear. How pronouns might support or hinder the acquisition of certain properties of the language by either creating very high frequency structures that can be easily memorized, or by creating very fixed phrases instead of more general phrases. So right now I'm working on a study where children are asked to decide which video matches the sentence that they hear, which is a standard comprehension approach. And we're looking at whether having a pronoun helps or hurts their ability to understand that structure. So I'm kind of excited about that.
Well, that's really cool. And I know a lot of your work focuses on acquisition of first language or native language. Do you think children are using different cues, or maybe even adults using different cues for learning additional languages beyond that first one?
I think it depends on when and how people are exposed to a second language. I would say certainly the approach that I took to learning French in college was very different from the approach I took to learning English as a young child. I had explicit vocabulary lists that I was memorizing. And,
flashcards,
someone sat me down and said, okay, this is the way the reflexive pronouns work in French. And obviously no one sat me down as a child and said, here's how reflexive pronouns work in English. Mm-hmm. At least not that I recall. And I don't think most children have that experience.
Right.
So I do think, because young children's first language is learned in an immersive situation where they're not receiving explicit instruction, they're just being exposed to lots and lots of examples, that's somewhat different from any kind of formal instruction. But I think if you were to talk about a situation where there is a child who has a first language and for some reason is uprooted and put in a situation where the community language or even the home language is very different from what they've been exposed to. So, for example, a child who's an immigrant at a young age might have a home language that is different from the community language, or a child who is internationally adopted at an older age goes from having one home language to a different home language. When you have that kind of late but early immersive acquisition, by which I mean you're not a baby anymore, but you're not a full-grown adult, then I think maybe some of the same processes might be coming into play as come into play for a baby. With adults, we have a harder time with learning languages than young children do.
Sure.
And we tend to want more explicit instruction. than young children receive. So I think there is a big difference between young children's acquisition, whether it's of a first language or of a second language very early in life, from adult acquisition of a second language.
Certainly. And now you mentioned that your work specifically looking at first language acquisition focuses on children kind of in the 6 years and under range. How early do you start bringing children in to look at language acquisition? Are you working with like 1-2-year-olds?
My studies right now are all with children between the ages of 3 and 6 years old.
Okay.
I have worked with children as young as 13 months.
Oh, wow.
And the graduate lab that I completed my thesis in does work with babies as young as 5 months old. So we go pretty young. There is work on babies who are days old. So we have ways of working with babies all the way down to newly born.
Yeah. So I was going to ask, how do you collect data on, or what are systematic ways you can gather information on children who are that young who might not be able to understand instructions very well?
Oh, they don't understand instructions at all.
Right.
They don't follow them, and we don't try to give them. So a lot of what we use with infant research is looking time. So how interested is a child in speech? And so we train them that when they look one direction, the speech will play, and when they look away, it will stop. And do they like to listen to certain kinds of speech longer than to other kinds of speech? And that technique can be used with any baby who's old enough to sit up and turn its head. Mm-hmm. We also use some methods where the child is looking at 2 different images, and then we play a word or a sentence and look to see, does the baby look at the right picture, at the matching picture, or at the matching video? So that's another technique that we use. With very, very young infants, those couple-day-old babies, there you see techniques like heart rate monitoring. So is there an increase in the infant's heart rate in response to certain sounds? That would indicate that they are aroused by those sounds. Or another thing that is looked at is the rate at which they will suck on a pacifier.
Interesting.
Babies who are really excited, like think of Maggie Simpson from The Simpsons, mm-hmm. right? When she's excited about something, she
goes faster and faster. Yeah,
exactly. And it turns out that real babies do that.
Wow.
So that's another measure that we can use to look at arousal. Interest might be a strong word to use given how young the babies are, but at the very least that it's something that is causing a change in their behavior.
Absolutely. Well, I know I complain about some of the challenges of working in older adults, but I imagine working in young kids is really, really challenging. So I really admire the work that you're doing there.
In some ways, they're easier because you don't give them instructions than older adults who can choose to ignore your instructions.
Right. That's true as well. Well, we've talked about a lot of the exciting aspects of your career and some of the work that you're doing, Erin, but I do want to chat about some of these challenges next. We've hinted at some of your research challenges in terms of working with very young children, but is there maybe a major challenge or failure that you want to chat with us about today to give us an example of some of the challenges scientists face and how you worked your way through this one?
Well, I would say that my hardest time professionally actually came right after my daughter was born. I think for any parent, becoming a parent is such a big life transition that you have to reorganize a lot of the way you work. In my particular case, my daughter was born early and she had some medical problems, and those have been resolved. She's fine now, 7 years later. But in that period where she was very sick and she was early, and I was a new parent, that was a really hard time for me professionally because I simply couldn't keep my attention and my time and my energy directed toward work-related things. It needed to be on her. So yeah, that's probably my roughest period as a researcher.
So what helped you get through that challenging time? It sounds like you're absolutely right. It's hard to focus even when you're at work, when you're supposed to be trying to get your grant submitted, papers written. What allowed you to get through that?
We've actually brought up a couple times this idea of a support network, and that is absolutely what got me through that period. Was I had a phenomenally supportive advisor at the time, and she went very much out of her way to make sure I had the time I needed to be flexible about meetings and short notice cancellation and financial support and those kinds of things. But in addition to her, all of the other people working in the lab, the other people in the department, my family and friends, those big things like being flexible about shifting times and short notice cancellations are huge. But so is just having someone who stops you when they see you and says, "How are you doing? How's it going?" Mm-hmm. I had a lot of that, and that was a really important source of support that people hadn't sort of forgotten what was going on. And I think that if you're in the sciences, making sure that you have a good support network is really critical because they can do a lot to get you through a truly rough period. And even periods that are not necessarily rough, but maybe just a bit uneven. I think that is absolutely critical.
Definitely. Well, Erin, I'm glad to hear that your daughter's okay now. And I'm glad to hear that you were able to make it through without this ruining your scientific career. Because I think that's something people worry about. If I start a family, will I have time to also pursue my science? And in your case, you had an additional challenge of some medical issues, and you were still able to pull through and keep your career going, which I think is awesome.
It was a close call.
Yeah.
It was tough, but yeah, we made it through.
Definitely. Well, I don't just want to talk about your tough times, Erin. I do want to talk about your successes next. So can you share with us one of your exciting success stories, whether it was a big win or even just a small victory that was really meaningful to you?
Most recently, I actually just came back from a really small workshop that I was a little bit nervous going into because it was a little bit outside of what I usually do, but it was a really great experience. My talk went very well. I learned a lot, and I also have new collaborations starting up as a result. So, I mean, that's not a huge finding or a major publication or any of those kinds of markers, but it felt like a really great experience and a very successful meeting to attend for me. So that was really one of my more recent successes, I think.
Awesome. Well, congratulations. Great to hear that your presentation went well and that you've got these new collaborations. So can you tell us, what was this talk about, or what are these new collaborations or new directions that your research is going?
The talk that I gave was about children's experience with homophones, words that have more than one meaning. Mm-hmm. So something like bear to mean the animal and bear to mean uncovered, and sort of how children experience them and whether there are differences in the way that they are pronounced or in other features of those words that might be of interest. So the context in which they're used, like I said, differences in pronunciation, and whether children can use that information to learn a second meaning for a word that they already know. And so the project that I'm hoping to get started up is actually related to some previous work I've done, but with a new collaborator and with a new perspective on whether being a noun or being a verb affects the way in which a word is pronounced and whether that information might be useful to people who are listening to language or trying to learn language, like children.
Gotcha. Well, very cool to hear more about these projects. I think these conferences, these workshops are great opportunities to meet new people and to have these conversations that lead to fruitful collaboration. So fantastic to hear that you had this experience. And we've touched on travel. You mentioned that you are traveling quite a bit these days to the point where you're able to read quite a few books, I'm sure, on the airplanes. So can you tell us a little bit about one of your travel experiences that just sticks out in your mind as the most memorable or your favorite place that you've been for science?
I've had the benefit of going a lot of really great places, usually for conferences and workshops of various kinds. One of my favorite, and it has absolutely nothing to do with the science, but one of my favorite conference trips was to Nashville several years ago. And Nashville is a great city. I was there for a conference, and the conference happened to overlap with my birthday. So a group of us went out to hear some music, and the place we ended up was kind of a dive.
Awesome.
It was really a dive, actually.
Let's not sugarcoat it, yeah.
But the band was amazing. And it turns out, like, we looked it up later, and the lead guitarist has a Grammy and all that kind of stuff. But we didn't know. We just kind of went in. But someone who was in the group with me, because it was my birthday, tipped the band and asked them to play Happy Birthday.
Aww.
And because it was like a jam-style blues band, it was a 7-minute version of Happy Birthday.
Wow.
Which was kind of embarrassing. But it was also, without question, the best version of Happy Birthday that I have ever or will ever be on the receiving end of. So that's probably one of my better conference travel memories. Although Nashville was great, even if that hadn't happened.
So what did you do during this 7-minute long ballad of Happy Birthday? I know it's awkward enough for me to like sit there for the 30 seconds or so.
Well, fortunately, they didn't ask where I was.
Oh, good.
So people weren't like looking at me, and it was kind of crowded anyway. So as soon as it started, my first reaction was to be sort of mortified, and I'm sure I turned bright red, and I know I slid down in the chair to try and hide.
Yeah.
But by the end of it, everyone was having so much fun that it was okay.
Gotcha. Well, that sounds like a fantastic conference experience, a wonderful memory to be attached to it. So can you tell us a little bit about what the conference was?
The conference was a meeting of the Cognitive Science Society, which is a big meeting held every year, usually in a different city. So I don't think it's ever been in Nashville again, but it's always someplace interesting.
And I think these are wonderful opportunities, too, to reconnect with some of your old colleagues from previous laboratories as well, especially these annual meetings that everyone tends to go to.
Oh, absolutely. That's my favorite part often. Hearing about the science is great, but being able to check in with people who I only see once a year and hear what's going on in their labs, even if it's not what they're talking about at the conference, that's in some ways the best part of those kinds of meetings.
Definitely. Well, now that we're on the subject of the people in science, I think the people in science are part of what makes it so wonderful to work in. And there are some stereotypes out there about what scientists are like, and we love to break them on our show because I think there are so many different types of people and personalities in science. And you see these manifestations through quirky traditions sometimes, or just funny or amazing memories from when scientists are spending time together. So, Erin, do you have one of these sort of human side of science stories or memories that you can share with us today?
Well, in terms of lab traditions and quirks and things like that, I'm not sure I'm going to break up any stereotypes here, because I think one of the stereotypes of a professor, especially a fairly senior researcher, is their office is just full of stuff, piles of papers and that sort of thing. So the lab I finished my PhD in had an annual tradition of cleaning out our principal investigator's office for his birthday.
Oh,
yeah.
That's a good gift. I'd take that now.
I know, right? And it would take the whole afternoon. And what was amazing is that even though we did it every single year, I mean, we did this once a year, it would be a complete disaster by the next year, always, again. And every year we would somehow unearth something ancient that we hadn't seen the year before. Right. So even though like a year ago we cleaned out this office, somehow there's a new stack of papers from the early 80s.
Oh, wow.
That just regenerated in a corner or something. So like I said, it doesn't really bust the stereotype of the distracted academic with the messy office. But that was a standing tradition in our lab. And frankly, it was more for us than for him, because the tidier his office was, the more likely we were going to be to get things done.
Oh, absolutely. So now, can you tell us, was this something that, do you think he was feeding into it? You know, was he finding weird stuff to plant places for you guys to find?
I wouldn't put it past him.
Yeah.
Yeah.
And have you kept this tradition now going on in your current laboratory? Do you have an annual cleaning of your office?
I probably should. I need to mention that to my students.
Yeah, suggest that.
That's a great tradition.
I love it. And I think in addition to spending time together, cleaning offices, doing research, it's fun to dream big with your colleagues and talk about maybe the questions that you're not able to address right now, but you would eventually like to in the future. And I think oftentimes as scientists, we find that there's always something standing in the way. And oftentimes it's funding, maybe technology, feasibility. There's always a barrier that keeps you from being able to answer these big dream questions. So, Erin, if we got rid of all of the barriers, if things like funding, staff, technology, feasibility for today were not a problem, can you tell me, is there one question that you are dying to answer?
Do I only get one?
We'll start with one.
Yeah, we'll start with one. For me, one of the biggest barriers in my research is that my research is with children under the age of 6. And so there are internal processes. All I can observe is their behavior. I can't necessarily observe what's going on in their heads before they get to the behavior. And even if we use technology like an fMRI or an EEG or other sort of neural imaging, that just tells us what parts of the brain are active, not necessarily what they are doing. Mm-hmm. And I think what I still really want to know, and this is an awfully big question, is what's going on in there? And in particular, when it comes to language, how much of children's apparent understanding of language is actually just something they're faking based on other information?
Interesting.
That's a big question for me. I can observe that if I hand a toddler a piece of paper and say, can you go through this way for me? They'll happily do it. But is it because they're actually understanding what I'm saying? Or is that because they're picking up on some other information in the situation? And I don't think we know the answer there. And that's a big one for me, is how much is coming from sources other than the language, and how do they incorporate that information?
I love this. I've never really thought of this kind of faking understanding, but I think you're right. You bring in all these contextual cues of sort of what you're supposed to do. And I find myself doing this even now in scientific talks. You're sort of perplexedly nodding your head, faking understanding. But can you tell us, if you had all of the tools, all the resources available, how would you maybe even start to tackle this?
Yeah, I don't know.
Yeah.
I mean, we do all these studies where we very carefully control what children are exposed to, or how questions are phrased, or what other information is available to them. And that's sort of one way of getting at it. But again, we can really only observe the stimulus and the response. there's not a good way to get inside their heads. But in the original question, you said feasibility. If feasibility weren't an issue. So I'm pretending like getting inside their heads is not an issue.
Right. We'll give you the gift of feasibility for today. I like it. Well, fantastic question, Erin, for us to ponder. And I think as you go through your career, not only do you get to start to chip away at some of these exciting research questions, but you also are exposed to a lot of wonderful people. As we chatted about, you have this network of scientists that you're building up around you, and they're often wonderful sources of advice throughout your career. So, Erin, is there one piece of advice that sticks out in your mind as just the best piece that someone has ever given you?
Oddly enough, the best advice I've ever received in terms of keeping me going and keeping me focused on my career as a researcher came from a playwright who was teaching a seminar I took as an undergraduate.
I like it.
And the thing that he said was, if you have 100 ideas, 98 of them will be crap, and one of them will already have been done. And that seems like kind of depressing advice when you think about it. Mm-hmm. But what you have to realize is there's still an idea left, and that it's worth it to go through all of your bad ideas. I took it as basically permission to have bad ideas and to explore those bad ideas and then to reject them as bad ideas. And I think that's a skill that has been more important in research than I realized it was going to be, was accepting that some of my ideas are bad and that's okay. And so that's the advice that I actually give a lot and always credit. I guess the original source was a playwright, but it is something that I remind myself of regularly.
Absolutely. And I think this sort of emphasizes the creativity needed to be a successful scientist, right? You have to come up with 100 different creative, innovative, interesting ideas, potentially to even have one of them be something that you can follow or sort of a quote unquote good idea. So do you find that this creativity is something that you're able to successfully harness in your current career?
Sometimes.
Yeah.
I may be broadly overgeneralizing here, but I think there are a lot of people who don't realize that science actually is a really creative profession. It's not just about going one step to the next. To have science move forward, we need people who think differently from the people who have already been thinking about a problem. And that generating new ideas is part of that. And that generating ideas that are worth pursuing means also generating ideas that turn out not to be worth pursuing. But that's part of anyone's creative process, whether they're a scientist or a writer or an artist of any kind. So I think science has more in common with the arts than it looks like at first glance, but we are all engaged in the project of figuring out which ideas are worth following up.
Definitely. And I think sometimes pursuing a crazy idea, maybe testing a crazy sounding hypothesis, you often find out that it perhaps wasn't so crazy to start off with, which is a nice surprise, I think, sometimes.
And sometimes it is just as crazy sounding as you thought it was, and that's okay too.
Right. That's okay. Yeah. Mark that off as a Thursday, a productive Thursday. I like it. Well, Erin, wonderful to hear about one of these helpful pieces of advice that you received. And is there any other last piece of advice you want to leave our listeners with today, now coming from you, or maybe a last note of inspiration you want to leave them with?
I think the thing that will help anyone be successful in science is being good to the people around you and surrounding yourself with people who are good to you. That having a solid network that you can rely on and people who can rely on you will really be the only thing that keeps you going. And also that you should listen to feedback, even if you listen to it just long enough to ignore it. Absolutely.
And I think there's no shortage of feedback in science. Sometimes you wish you had less, but you have to take it. Well, I think this is a really important point to, again, emphasize here, this importance of a support network and having those people around you to help you through these rough patches and to celebrate the good times with you as well. So thank you for bringing that up again, Erin. Wonderful to have you on the program. Can you tell our listeners now how they can reach out if they want to learn more about you and the work that you do?
Sure. The best way to contact me would be on email. And my email address is Erin, that's ERIN, .r.conwell, CONWELL, @ndsu.edu.
Perfect. Well, listeners, definitely reach out if you have any questions. And Erin, it has been a pleasure to chat with you today.
Oh, thank you so much for having me. I've enjoyed this.
Well, this was a lot of fun. And listeners, I hope you enjoyed it as well. We'll see you next time on another episode of People Behind the Science. Your voyage to explore the lives of today's exceptional scientists has just begun. You can find everything we talked about today, including our guests' favorite books, biographies, photos, and more, when you visit us at www.peoplebehindthescience.com. I look forward to chatting with you next time on People Behind the Science.